Hi again. In this video, we're going to talk more about alpha so that we can learn how to choose a significance level for a test. Okay, so let's say in a specific situation, let's say the null hypothesis is true. Okay, so meaning it's actually true in real life. Okay, and we have a significance level of 0.05. So this is the threshold for rejecting the null. And I've got a picture here, just like when we find our test statistic and then we find our p-value. This area is 0.05 right here, okay? So this is the threshold. If it's if our p-hat is to the right of this, or our z-score is to the right of this, it'd be smaller, we'd fail to reject, right? And this is the threshold for rejecting the null. And when we do that, we're saying it was a significant result, right? It didn't happen by chance. It was statistically significant. That's why we reject the null. There's a small, small p-value. Okay, so the result did not happen by chance. Okay, so what we're saying here is that we're willing to reject the null if there's less than a 5% probability that the observed result did happen by random chance, meaning we make an error. Okay, so the probability of making a type 1 error is the same as alpha. Okay, alpha is the chance of making a type 1 error. And that's the significance level. Okay, now the chance of making a type 2 error, we're not going to be able to calculate that. Probability of making a type 2 error, but we're going to label it and call it beta, okay? It can be calculated, but it's a little more complicated. It requires having another hypothetical value. It's just beyond the scope of our course, okay? It's not that you couldn't do it. But I just want you to understand the relationship between alpha and beta, okay? So beta is the probability of making a type 2 error. There's a trade-off between these, okay? And that's why we were talking about which one is worse. So there's a trade-off between alpha and beta. If we make alpha smaller, then beta gets larger, and vice versa, okay? So the neutral level, and this is why 0.05, we finally learn why 0.05 is the default. That is considered the neutral level between making a type 1 and type 2 error, okay? So in the situation, if making a type 1 error is more dangerous or costly, then we should make alpha smaller. Okay, so if a type 1 error is worse, we want to make it harder to reject. So we make alpha smaller, like alpha equals 0.01, okay? If, on the other hand, making a type 2 error is more dangerous or costly, then we should make alpha larger, like alpha equals 0.10. Those are some of the common ones you see. And so let's go back to the previous page, and I want to write in for those examples what we would choose. So we had one of each. We had this in the previous example, part A, where a person tests to see if they're pregnant, and type 2 is generally considered to be worse. So type 2 error, then we would make alpha bigger. So let's say we would do alpha equals 0.10 for that one. And then in the court trial case, type 1 is generally considered to be worse. But again, if you're doing the study, you're making this decision, we would say alpha equals alpha be 0.01. Okay, so remember, we're doing all this before we actually collect our data. We're setting up our test. And so you would want to do this analysis of, okay, what would a type 1 error be? What would a type 2 error be? And how do we want to set our alpha? Okay, and then the 0.05 is considered to be the medium balance between type 1 and type 2. Okay, great. I'll see you in the next video.